In today's digital landscape, understanding the domain name system, or DNS, is crucial for anyone who uses the internet. So, what exactly is DNS? Simply put, it's like the phone book of the internet. When you type a website address into your browser, DNS translates that human-readable name into an IP address that computers can understand. This process is essential for navigating the vast online world, allowing us to access websites, send emails, and connect with others seamlessly. But why should you care about DNS? Well, it plays a significant role in your online experience. Without DNS, we would have to remember complex numerical addresses for every site we wanted to visit, which would be a daunting task. Understanding how DNS works can also help you troubleshoot common internet issues, enhance your online security, and even improve your browsing speed. In this video, we'll dive deeper into the fascinating world of DNS, exploring its components, how it functions, and why it matters to you as an everyday internet user. By the end, you'll have a clearer picture of this vital system and how it impacts your daily online activities. So, let's get started. What is DNS? DNS stands for Domain Name System, and it serves as a fundamental pillar of the internet ecosystem. At its core, DNS is responsible for translating human-readable domain names, like www.example.com, into numerical IP addresses, such as 192.2.1. This translation is essential because, while we prefer to remember easy-to-read names, computers communicate using these numerical addresses. Imagine trying to navigate the internet without DNS. You would have to memorize a long list of IP addresses to visit your favorite websites, which would be incredibly cumbersome. DNS simplifies this process, allowing users to access websites effortlessly. When you enter a domain name into your browser, DNS acts like a translator, quickly finding the corresponding IP address and directing your request to the correct server. The critical role of DNS in connecting users to websites cannot be overstated. It ensures that when you click on a link or type in a URL, you are seamlessly directed to the right destination. Without DNS, the internet as we know it would be chaotic and nearly impossible to navigate. Understanding DNS helps you appreciate the behind-the-scenes technology that makes your online experience smooth and efficient. How DNS works. The process of how DNS resolves domain names to IP addresses involves several key steps that happen almost instantaneously. When you enter a domain name into your browser, your device first checks its local cache to see if it already knows the corresponding IP address. If it doesn't, the query is sent to a DNS resolver, typically provided by your Internet Service Provider, ISP. The resolver then queries a series of DNS servers, starting with the root DNS servers, which direct the resolver to the appropriate top-level domain, TLD servers, such as those for .com or .org. From there, the resolver contacts the authoritative DNS server for the specific domain, which holds the DNS records. These records include various types, such as A records that map domain names to IP addresses, C name records that alias one domain to another, and MX records that specify mail servers for email delivery. Once the resolver retrieves the correct IP address, it sends this information back to your device. To speed up future requests, the resolver caches the result for a predetermined time. This caching significantly reduces the time it takes to resolve domain names on subsequent visits, enhancing your overall browsing experience. Understanding this process highlights the efficiency and complexity of DNS in our daily internet usage. Types of DNS records. DNS records are essential components that help manage how domain names function on the internet. Each type of DNS record serves a specific purpose, ensuring that users can access websites and services efficiently. Let's explore some of the most common DNS record types. First, we have the A record, which maps a domain name to its corresponding IPv4 address. For example, if you have a website at www.example.com, the A record would point to its specific IP address, allowing users to reach it easily. Next is the troubleshoot record, similar to the A record but designed for IPv6 addresses. As the internet transitions to IPv6 for more address space, troubleshoot records become increasingly important for modern websites. CNAME records, or canonical name records, allow you to alias one domain name to another. For instance, if you want www.example.com to point to example.com, you would use a CNAME record. This is particularly useful for managing subdomains. Lastly, MX records, or mail exchange records, Specify the mail servers responsible for receiving email on behalf of a domain. For example, if you set up email for your domain, MX records direct incoming emails to the correct server. Understanding these record types is crucial for effective domain management and ensuring seamless online experiences. DNS security. As the backbone of internet navigation, DNS is not without its vulnerabilities. Understanding these security aspects is crucial for protecting both users and organizations. One common attack is DNS spoofing, where an attacker alters DNS records to redirect users to malicious sites, often leading to phishing or malware infections. Another significant threat is distributed denial of service, DDoS attacks, which overwhelm DNS servers with traffic, rendering them unable to respond to legitimate requests and causing widespread outages. To combat these vulnerabilities, DNSSEC, or Domain Name System Security Extensions, plays a vital role. DNSSEC adds a layer of security by digitally signing DNS records, ensuring that users receive authentic responses from DNS servers. This helps prevent attacks like DNS spoofing by verifying the integrity of the data. In addition to implementing DNSSEC, there are several best practices for securing DNS configurations. Regularly updating DNS software is essential to patch known vulnerabilities. Using strong, unique passwords for DNS management interfaces can prevent unauthorized access. Additionally, limiting the exposure of DNS servers to the internet and employing firewalls can help mitigate potential attacks. By understanding these security aspects and implementing best practices, users and organizations can significantly enhance their DNS security and protect their online presence. Future of DNS. As the internet continues to evolve, so does the domain name system, DNS. One of the most significant changes on the horizon is the transition from IPv4 to IPv6. With the growing number of devices connected to the internet, IPv4 addresses are becoming scarce. IPv6 offers a vastly larger address space, which will require updates to DNS infrastructure to accommodate these new formats. This transition is crucial for supporting the future of the internet and ensuring seamless connectivity. Another emerging trend is DNS over HTTPS, DOH, which enhances privacy and security by encrypting DNS queries. With DOH, users can send their DNS requests over HTTPS, making it more difficult for third parties to intercept or manipulate these queries. This not only protects user privacy but also helps prevent attacks like DNS spoofing. Looking ahead, we can speculate that DNS will continue to evolve alongside advancements in internet technology. As the Internet of Things, IoT, expands, DNS will need to adapt to manage the increasing number of connected devices efficiently. Additionally, innovations in artificial intelligence and machine learning could lead to smarter DNS management, optimizing query responses and enhancing security measures. Overall, the future of DNS promises to be dynamic, addressing new challenges and opportunities in our increasingly connected world. Conclusion. In this video, we've explored the essential role of the domain name system, or DNS, in internet navigation. We discussed how DNS translates human-readable domain names into IP addresses, allowing us to access websites effortlessly. Understanding DNS is crucial not only for navigating the web, but also for troubleshooting common issues and enhancing online security. We also highlighted the importance of being aware of DNS security, including potential vulnerabilities like DNS spoofing and DDoS attacks. Implementing measures such as DNSSEC and following best practices can significantly improve your online safety. Additionally, we touched on emerging trends, including the transition to IPv6 and the benefits of DNS over HTTPS, which promise to shape the future of DNS. As we move forward in this digital age, staying informed about DNS and its evolving landscape is vital. If you found this video helpful, we encourage you to subscribe to our channel for more insightful content. Don't forget to like and share this video with friends and family who might benefit from understanding DNS better. Your engagement helps us create more valuable resources for everyone navigating the complexities of the internet. Thank you for watching, and we look forward to seeing you in our next video.